Dear students, already we know and we have gone through the numerical methods to solve the linear system of equation. We also know the methods to solve the system of equation as Jacobi's method and Gauss-Seidel method. And further, there is a very unique and special condition and which is known as ill-conditioned system of equation. So what do you mean by ill-conditioned system of equation? A system of equation where a small changes in the coefficient result in large deviation in the solution is said to be ill-conditioned system. Such type of equation are very sensitive to round off error. How? Just here you concentrate yourself and look in the matrix form, because we know the linear system of equation, that is ax is equal to this is always we know a into x is equal to b. So this is a linear system of equation we know. Okay, so in the particular case in the matrix form, we may write this as that a small deviation in the entries of matrix A cause a large deviation in the solution. How? Just to concentrate here in this matrix, just to look the values 1, 0.482 and 0.99, this column matrix x1 and x2, if this is the constants b are given 3 and 1.47, and it means if you solve then you look how it will look like. This you may write like this: after this solution and equating the matrices, you will get the two equivalent matrix like this. But here just you observe here, if a small change here for 0.48 and 0.49 and rest all the entries are the same, then you notice here this value is 1 1, but here this is 3 and 0 with a small change. It means huge change here. Why? Because you know to solve the linear system of equation, we always equate, we always go and obtain such position where equivalent of two matrices, and then equivalent of two matrices give you x1 is equal to 1 and x2 is equal to 1. But here after this slight change here, this will be x1 is 3 and x2 is 0. Then how you look further, it will be clarified in the next PPT. If let us take one example, so that the following system of equation 3x1 plus x2 is equal to 9 and 3.015x1 plus x2 is 3 is ill conditioned. So we have to establish this. So how we can establish? The solution of the system is may be written as x1 is equal to 9 minus 3 divided by 3 minus 3.015, and this value is minus 400, and x2 is equal to 1209. Just to look. Okay, and if you go further and you check the by taking this equation. How? By taking this equation, now we round off the coefficient of x1 in the second equation to 3.02. Okay, if you round off this 3.02, then the solution of the given system will be x1 is equal to 9 minus 3 divided by 3 minus 3.02, and this is about minus 300. And after putting the value, you will get x2 is 909. Just imagine with a small change round off here and the huge change in the value of x1 and x2 now. It means putting these values of x1 and x2 in the given system of equation, we have the residuals as r1 is equal to, just to check the remainder term, so minus 900 plus 900 minus 9 is equal to 0. But here r2 with this set of equation 3.015 multiplied by this value, this minus 300 plus 909, this value here, and then minus 3. Then here you will get not 0, this is 1.5. It means the first equation is satisfied exactly, whereas we get a residual for the equation. This happened due to rounding of the coefficient of x1 in the given system of equation. Therefore, we can say that the system in question is ill conditioned. So this is the way how to prove the ill-conditioned system for the given set of equations. If you go and you look once again in other way or in other languages, then you will find you can redefine like this also. K small change in coefficient result in large change in the solution, or small change in input is large change in the solution. Okay, alternatively, a wide range of answer can approximately satisfy the equation. So, it means for any linear system of equation, there are two things. One is ill-conditioned system, another is well-conditioned system. So small changes in coefficient result in small changes in the solution. That is called well-conditioned system. And we have already gone through various across the various examples. But ill-conditioned system means small changes in coefficient result in large change in the solution. It means and now for the problem, a different set of problem you can do the practice. Okay, if since round of error can induce small changes in the coefficient, these changes can lead to large solution error in ill-conditioned system. Okay, so these are the problem x1 plus 2 x2 is equal to 10, 1.1. Just to look here, the coefficient is 1, but here you have taken 1.1 x1 plus 2 x2 is equal to 10.4. So in this way, in the form of matrix also you can find out the values. So in this way you can establish the result. Now, for example, this is for your practice, so that the following system of equation are ill-conditioned. Twice x1 plus x2 is 25, 2.001 x1 plus x2 is equal to 25.01, and y is equal to 2x plus 7 and y is equal to 2.01 x plus 3. So this is, we have to establish this system.